So this is chapter 12, all about files. It's a very good, very comprehensive chapter with a lot of things. And even if this was an in-person course, there's just so much that Mr. Gaddis does covering this chapter. It's really well written. I've seen a lot of books on how to do files, reading, writing, parsing them, internal, external, appending to them. It's really well done. So enough of singing the praises. Let's start looking at some projects with here and what we want to do with our code, so that way you're up and ready to do the lab assignment. So, file, new project. Okay, console app, C++. Project title shall be lecture, what are we calling the other ones? Lecture 12A in files. Again, because we don't know how many times it's going to crash. Thank you, code blocks in Windows. All right, so we hit next. Now, what's going to be critical is where are our external files going to be located. So we have that folder that we save everything in. And here's the file that I just created right now. And I have a little file here that's we're going to use hand in hand with this file. I'm going to need to drag it into the working directory. CodeBlocks does a funny thing with opening files, and I'll show you that as our lecture goes on. But first things first, I'm going to minimize this, go to main, and of course zoom in. Here we go. Okay, so whenever you work with files, you need to bring in a library. Pound include fstream for file stream. Since we're going to be working with strings, I might as well bring that library in as well. Pound include, we're going to bring in the high level string object, not the string arrays or anything like that. So string objects and the file stream. Okay, so the book talks about fstream objects. If I say fstream and input file, that creates a file, but we have to set it with all sorts of properties. Is it an input file, or because it's called input file doesn't mean it's input? What I like, and it's also supported with the fstream library, is if I say ifstream for input file stream. That way we know it's going to be our in file for reading input files. I'll leave it at that. So ifstream in file. We're also going to be dealing with an output file stream, OF stream. Again, you can call them F streams and set the flags on them. Are they going to be reading into or from? So I'm going to call this one outfile 1, because we're going to have 2 output files when all this is said and done. Where's its location? Well, unfortunately, normally you can just leave it alone and it will be in the working directory of where our external file is. Like if I compile this right now, it's going to warn me that I've created a whole bunch of things. Missing a semicolon. It's going to warn me that I've created a whole bunch of files, but it says I'm not being used. Over here, if I look at lecture 12a, here's our directory, here's the workspace, here's main. Technically, this file should be in the working directory here that we're going to create. But it doesn't happen that way with code blocks, so we're going to have to actually say where we want this to be. So, and because I'm on a Mac, I have to do it this way. So I'm going to create this output file, and I'm going to have to give it some parameters. The first parameter will be where it's located. Now, because I'm in Mac, I'm going to say /users. I have a special login here on my MacBook. RCBC is the name. It's the desktop. And of course it's in this RCBC folder, RCBC. And I will call it out1.txt. And let me widen this a little bit. Okay. Because now it's going to need what I said is a flag. And a flag are properties that tell this file how it's going to behave. Is it going to be opening it for input, Opening it for output. Do we destroy the data of the output file if it already exists? Do we append to it? And those are the flags. And again, they're discussed in the book, but this is going to be IO double semicolon out. It's going to be for output. Input output stream. This is the scope resolution operator. So whenever I say colon colon, I'll say scope. In our next chapter, in chapter 13, we'll be talking about classes. I'll do it again with the double colon being referred to as scope. Okay, so it's going to create this as an output file. All right. Now, if I wanted to append to it, I'll do that for the next one. I'll create output file stream out file 2, and I will lazily copy this, put it right there, and here I'm going to use the single logical OR. See if I can't move this over so you can see the whole big line. I guess that's not going to happen. Oh, there we go. iOS scope app, which means this is an output file. If it's found, append to it. Don't wipe out data. So here, this is output 2. So output 1 will open up and it will wipe out everything for appending, for writing to it. Here, it preserves it. So you may want that this flag set. So I'm just telling you that's what you can do if you want to append to it. This output file 2 is going to be another dumping ground, and we'll look at it every now and then and say, yes, you are appending. Do a save lest I crash. Okay, now let's see. Was the file created? Simple enough. I can say something like if out file 1. Just that. It will return a Boolean true if it actually created the file. Cout, I will say good create. It created it well. Okay. Else, this was bad create, or didn't create. Okay. Let's see. Cout, bad create. And a bad create is usually it didn't create it at all, or it opened up a file that it found but couldn't write anything, so what did it do? It did us the favor and wiped out the data. Okay, what's lingering down here? The hello world and the return. Okay, we'll get rid of that. Okay, so let's run this. Okay, compile, run. Okay, good create. Let's look. There it is, output 1, output 2, within this Lecture 12a folder, because, well, no, it's not within that. It's in the root of this RCBC folder, which is on the desktop with my login as a user. So if you're using Mac, you have to do this. If you're using a Windows product, C:\users, etc., some kind of a file. And so when it comes time for me to grade your projects, I'll monkey around with this. In fact, what we're going to do is we're going to create a stream that's going to ask us where do we want to save this, okay, or where do we want to read from. Okay, so I'll minimize that. I'll close out these terminal windows. Okay, so that's for creating output files. That really didn't do anything wonderful. In fact, if you want to see something next time we run it again, we assumed it created output file 2, so I'm going to say this, out file 2, say some data. All right, so next time we run this, output file 2 is going to have some data put in it. Okay, and every time we run this, we're going to have some data again and again and again. Why? Because, and just like a file, it will recognize new line characters. It will have it again and again because of the append directive. Okay, so now how about reading an input file? Well, let's create a string object. String file name. And this will be what we ask from the user. Okay. And we have our file stream in file created. So I'm just going to give a friendly cout and say, welcome to Lecture 12 Files. All right. And let's do this. Cout enter an input file name. And we'll use the getLine command. GetLine using a cin and the file name. So now this should read in wherever we direct it to find a file. And let's see, let's just echo back to see what we entered. Okay, so I'm going to say cout, you entered this file name. Okay, so let's, again, taking in baby steps, we'll compile, we'll run. Oh, you know what? Since we're here, let's do some things. Let's, we've created in file, and it's going to read looking for input files. So let's set it as this, similar to what we did with the output file. I will say in file dot open. So I have these handles from a file stream that's going to open something. What's it going to open? Look for this file name and set it a flag. Now, because this was born of an input file stream, we don't need to set this flag. But when we open it as a generic fstream, file stream input file, we have to set that flag. It won't know whether it's going to be, oh, not open, in, sorry. It will be, whether it will be for input or output. And let's just say, were we successful? If we could open the in file, so again, it's a Boolean just saying, yep, you were successful, we will say file found, right? Why not? Else, file not found. And I'm waiting for that crash to happen because I can detect that I'm typing faster than it's echoing to the screen. Okay, compile. Run it. Okay, enter an input file name. What was it? /users/rcbc/desktop/rcbc. And this input file name was called pre.txt. Hit enter, and it was found. Okay. First things first, what is in pre? I just put in some common phrases you might see in the Constitution. We the people, when in the course. Churchill's famous, I have nothing to offer but blood, toil, tears, and sweat. The rough draft of Lincoln's Gettysburg Address said 66 years ago. Okay, he had to fix that, etc. Okay, so these are some famous lines. We're going to read these lines and parse through them and look for things. We're going to count these lines. What do I have? 7 lines here. So it's going to let us know how many lines we have in our text. Okay, so that's what pre.txt has in it. Okay, and while we're at it, let's look at out2. Some data. Okay, and if I run it a second time, it should have another some data in there. In fact, well, we'll wait. Okay, we got some more to type. Okay, all right. Oops. So let's, now that we have the file open, when files open, they always start at BOF. That stands for beginning of file, and they will then traverse through the file till it gets to, obviously, EOF, the end of file. So how do we want to stomp through this file? Character by character? Line by line? Are we opening up in binary mode, which is 1s and 0s? All of that is laid out, again, in Chapter 12 of the Gaddis book. What we're going to do here is we're just going to use string objects and read lines at a time. You just came off of a project where we're taking strings and parsing through them. I'm going to show you some other string tips and tricks. Again, all cumulative based on what you've learned already. Okay, so let's look at this. I'm going to create a counter. I'm going to say int count equals 0. And we're going to count how many lines are in our code. So it's going to be a while loop. So I will say while get line of in file can be sent to, I have a variable called line of text, which I haven't created. I'm going to create that right now. Okay, let me put that here. We're going to say this. String line of text. And what we're going to do is we're going to use file read utilities to just read one line at a time. If you want to read one character at a time, then we have get characters, put characters. Right now I'm reading one line at a time. So let's see. Let's echo back to the screen the line of text. Now, when it's reading it, it's going to read the line, but it's not going to capture the end of line character. So we have to kind of put that in ourselves. So let's run this. In files, because it's a capital F, of course. Okay. Okay, I've got some unused variables. Let's run it. Okay. I'm going to get lazy and copy this line up here, paste it there, and put in what, pre.txt. Then I'm going to copy it again. I can do this because every time I run this line, instead of typing this all out and boring everybody, I'll have it copied, I'll paste it in there. Okay, enter. Okay, well, look at that. It found the file and it stomped out the 7 lines that are in the file. Okay, here's what I'm going to do. At the end of each of these, I'm going to output the count and then an end line. What I'm going to do is I'm going to increment the count by 1, and then we'll put it out. Okay, so save it, run it. Does paste work? Beautiful. Okay, look at that. At the end of each line are the number of lines. Then we have a stray line because it printed it out, but there was nothing there at the end. This is EOF. But when we do hit the end and there's nothing left to read, we'll be done with our processing. Okay, good. So let's close this. Okay, so good stuff. We can read through a file. Let's take that information and dump it to one of our output files. Oh, and speaking of output files, let's look at out.txt. Okay? Yep, we've run our code 3 times. It's appending it. The first out.txt has nothing in it. It opens it up, but puts nothing in it. In fact, you can see over here, 0 bytes. Let's put something in it. Let's, in fact, when we have this open, let's write to the input file. So, same way with output stream operators, I will say what? Out file 1 will have the line of text sent to it, and also an end of line character. Okay, so build, run, paste, enter. Okay, let's look here at our file. It's got 231 bytes to it. Let's look. There it is. Okay. So now we're reading from output file, dumping the contents back into another. Maybe if we wanted to do some kind of a dot substring of that. Let's grab the first 3 characters. Okay, I know there's at least 3 characters in each of these lines. And we're doing something a little shameful right now. Whenever we open a file, we are forgetting to close them. So as our next to last line before we hit the return 0, invoke a close method. Now C++ automatically it invokes a close, but it's good form to close it on your own, because if you don't, you run the risk that if your file is somehow open and it's a network file, let's say, and someone else opens it up and changes it, and you also have a file handle to it and it's open but hasn't been closed, you run the risk of corrupted data, that you'll overwrite what they took out, or as you're waiting, you needed to hit enter to continue some process, someone else went in and changed it and you didn't know about it. So always good practice to do it. Like I said, it will invoke it directly when you exit out of it, but do a solid close to it. Okay, compile, run, paste. All right, so now let's look. Did we grab in the output file the first 3 characters? I'm going to guess we did. Look how small it got. Instead of 231 bytes, it's much smaller now. Out 1. Look at that. Okay. All right. So now you know that you can read input. You can play around with it before you send it out to some output file. Let's see. Let's also search the string, because that's part of your lab. So what this means is we're going to be going back and using some of the tools that we learned with string objects. Here's something a little fun. I'm going to put this in. I'm going to say if count mod 2, no, not cout, but count. If count mod 2 is equal to 0. So what that's going to do is it's going to, I don't want to copy that because I got my other thing in there. I'm going to keep that. Come on, curly brace, move over. Okay, tab U in. I'm going to get rid of this substring method. I'm just going to put the line of text in. Okay, what this means is only even numbered lines, right? Count mod 2 is going to return a 0 or a 1. 0 means it's even, 1 means it's odd. I'm going to only return even numbered lines to that output. Okay, so let's compile and run. Okay, and there it is. Let's look. Here's the pre-file. Here's the out 1. Yep, lines 2, 4, and 6 got pasted there, put there. Okay, good. All right, so now we can select what we want to put in there. All right, close this. Let's see what else I kind of played around with. While we're in this get line, this line of text is now that capture of that line of code. So let's look for something. I'm going to create a new variable, string. I'm going to call it find this, and I want to look for an. Okay, the word an in the text anywhere that I find an a and an n, I want to report it out. So let me look at pre.text one more time. Okay. We the people, when in the course. Oh, I don't have permission to write it? Ah, I know why. Because I extended it out to another file that I was accessing. I had two sessions going on at once, and I was logging in as the administrator. That's why I can't access it. I can create myself another one. How about this? How about I do file save as? File. Will this let me do a save here? I'll duplicate it. There it is. And when in the course of human. There we go. There's an AN in there. Okay, so let me do a save. And I'm going to call it pre1. Saved in the same space. There it is, pre1. Okay, close that. The goal here is to look for anything with an AN in it. Okay, so how do we do that? Well, we're going to look for find this. We're going to create a new integer variable called found. Found will be a number that we're going to get as return output. If we do a search for a substring, using the find method from the string class, it's going to return the position that this string was first found at. There could be many others in the line, but it's going to find the first one. If it doesn't find it, it's going to return a -1. Okay, so armed with that information, right after here, I will say this. Found will be, line of text is our string, and using a dot find method, we want to find, what was it, find first was the name, or find this was the name of that string, and a second parameter is where do we start? 0, at the 0th position. Okay, and I'm going to say something like this. This is just going to be outputted. If found is greater than or equal to 0, meaning it could be the very first position. I don't remember any lines beginning with AN, but just to be safe, start at 0. Then I will say something like cout find this was found. Okay, and let's echo back the line of text so we can see that in fact that it found it correctly in that line. And just for last, let's also echo out the variable found. That way we know at what position in the string. Not that it's going to matter. All we just want to do is find it, call it a day. Okay, so let's save this, compile, run it. Okay. It's not pre, but what, pre1? Okay. When in the course of human events, let's see. Oh, these lines are just, being brought out, but here, at position 25 is where human was found. I have nothing blood to offer but blood, toil, tears, and that's line 3, found at position 47. Okay, it was found in 4score and 6. A date which will live it wasn't found. And good day. Begins with a capital A and N. It didn't find it. It's case sensitive. And that's going to be part of your lab. You're going to actually ask the user for something to search. And just like when you do like global searches and replaces in text documents or in files, it's going to find it whether you put in uppercase or lowercase, unless you set some kind of case sensitive flag. but you want to find it in its precise manifestation. Is it uppercase or is it lowercase? Now, so let's create some kind of a function that's going to do this. And I'm going to leave this to you to write. String make upper. And some string s will send it. And what you're going to do is you're going to make the whole string uppercase. Unfortunately, there's no primitive utility to do that in a string object. So you have to come up with a way to take a string and return its entire uppercase. And I don't mind doing any Google searches to find some code, but understand what it's doing. And if you do find code and you use it, I don't mind you doing it, but you have to tell me where you found it. You have to give the author credit. It's kind of like honor among thieves. If you're going to take something from another programmer, we don't mind. In fact, we're glad that people are using our little mini masterpieces. Just give us credit for it. So here's what I'm going to do. Down here, in when the function is fully blown out, string make upper, and we give it a string object s. Okay, here will be make it uppercase, and down here return I'm going to return the word the. If I recall, we have the word the capitalized. Okay, so it's not going to look for an anymore. It's now going to look for the. Okay, so watch this. Oh, and of course, up here you'll say something like ask the user for a string to find. Okay, so find this. It says it's an, but we know that the make upper will force out the capital THE, and it's only going to find one instance of it. Okay, compile, run. pre1.txt. There's only one line where it was found. So it works. Well, it found capital THE, but that's going to be your job to write a make upper. So that way you'll find it at all times. Okay? And like I said, you'll find a lot in the book, in the chapter, all about flags. In fact, on page 666, table 12.2 gives you a nice whole output about the flags that we can pass. Also, grabbing single characters and outputting single characters. Maybe you want to investigate each character at a time. As you can see, we have one file, one program, with, in a sense, 4 files open at once. This one doesn't have anything in it, but it's still a file handle to something. The only thing I want to caution you about is when you move your file pointer in a file, there's no way to go back. You have to go all the way to the end or close the file and reopen it again. And sometimes I've given assignments where you have some input file, you send everything to an output file, and then you echo back that output file. And the only way to do that, see here we're kind of echoing it all along, but I could say something like this. Okay. But if you wanted to echo, let's say, out file 2 back to the screen, one line at a time, you would need to close it, reopen it as an input file, and read line by line and echo the lines to the screen. So you would do this directive after you close them. Okay, so it was born as an output file, close it, open it as an input file, with the same things. Check to make sure you wrote it, make sure you found it, make sure you can open it, and again, once you're done with that, close it. So I think this is a good background for reading input files, at least for what I want for your labs. Like I said, Chapter 12 is incredibly rich with what you can do with input files. Again, as our course progresses, there might be some instances where we want to save the data. There's a great section here about writing sequential access and random access files. A little bit beyond the lecture that I want to do here, but again, it makes for good reading, especially if you're seriously looking at a career in software engineering. Okay, I'm going to save this. Safko signing out, and good luck with the lab.